Hi, this is King of Review. In this problem, we want to solve the system of linear equations by using Cramer's rule. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use Cramer's rule to solve the system. That is, solve for x and y. So Cramer's rule is a method where we use determinants to solve the system of linear equations. Cramer's rule states that x is equal to the determinant of the x matrix divided by the determinant of the coefficient matrix. And y is equal to the determinant of the y matrix divided by the determinant of the coefficient matrix. So let's set up the matrices. Let's start with the coefficient matrix. So the coefficient matrix is going to be the coefficients on the x and y terms. So we have A, B, C, and D. The x matrix, this is equal to E and F, and you notice E and F are the constants, and then we have B and D. And then the y matrix, this is equal to A, C, E, and F. So this is how we set up the matrices. So let's fill them out using our specific values. So the coefficient matrix, what are the coefficients? We have 3, 8, 8, and negative 4. 3, 8, 8, negative 4. What about the x matrix? Well, we start with E and F, and those are the constants. So we have negative 16, negative 68, and then B and D, which are 8 and negative 4. And then the y matrix, we have A and C, 3 and 8, and E and F, negative 16, negative 68. So we've set up our matrices. Now you notice with Cramer's rule, when we solve for x and y, we need the determinants of these matrices. So what is a determinant? Well, a determinant is a real number that's associated with the square matrix. So let's say we have the matrix A, B, C, and D. So the determinant can be found by multiplying the entries in the main diagonal, so AD, and then subtract the product of the entries in the other diagonal, CB. So AD minus CB, this is how we find the determinant value. So let's do that for the coefficient matrix. The main diagonal, so we have 3 times negative 4, then minus the entries in the other diagonal, 8 times 8. So when we work this out, we get negative 76. That's the determinant of the coefficient matrix. Now let's find the determinant of the x matrix. So we have the product of the entries in the main diagonal, so negative 16 times negative 4, minus the entries in the other diagonal, or the product of the entries in the other diagonal. So we have negative 68 times 8. And when you work this out, you get 608. And for the y matrix, we have the product of the entries in the main diagonal, so 3 times a negative 68, minus the product of the entries in the other diagonal, 8 times negative 16. And when you work this out, you get negative 76. So x is equal to the x matrix determinant, and we solved for that here, that's 608, divided by the determinant of the coefficient matrix, that's here, that's negative 76. So we have 608 divided by negative 76, and this works out to negative 8. So we know that x is equal to negative 8. And now for y, we take the determinant of the y matrix. We solved for that here. That's negative 76 over the determinant of the coefficient matrix, negative 76. And this is equal to 1. So we know that y is equal to 1. So the system of equations, the solution is x equals negative 8 and y equals 1. So letter E is correct. Thanks for watching.